Hello guys, let us continue our topic real numbers. In today's video I am going to show you the irrational numbers, proof of irrational numbers. Now first, what are the irrational numbers? Now irrational numbers you have studied in class 9. Here I have written the definition. The numbers which cannot be expressed in the form of P upon Q. P upon Q is a rational number. So the numbers which cannot be written, cannot be expressed in the form of P of Q are called irrational numbers, or whose decimal form is non-terminating, mean does not stop, does not terminate, and non-recurring, and repetition of the numbers or digits is not there. So no repetition and no stopping, I mean continuously. That is called decimal form. So such type of numbers are called irrational numbers. And you know that the natural numbers whose root cannot be taken, like root 4, whose root is not a whole number. Root 4 we can take. Root 4 is, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. But the square root of 2 will be in this form. If you find the square root of 2, you will get this type of number. So root 2, root 3, root 5, root 7, root 10, root 11, root 13, root 15, and all these kind of numbers are called irrational numbers. And this is the example of decimal form. 2.01, how to write? 2.01, increase 1 0 1, again increase 1 0 1, again increase 1 0 1. Like that you can write. Now questions from the textbook. Prove that root 2 is irrational. Now we'll use the indirect method of proof. 2-3 things you have to remember here, and you have to understand properly. Follow all the steps and go through properly. Now first of all, we'll assume it as this is not irrational. If it is not irrational, then it must be rational. You know that the real numbers are two types, rational and irrational. If it is not irrational, then it will be rational. So let us assume that root 2 is rational. This is your first point. And you know that a rational number can be written in the form of P upon Q. So let root 2 is equal to A and B, where A and B are co-prime. Now what do you mean by co-prime? Co-prime are those numbers which do not have any common factor. For example, see here, 2, 3, 2 and 3. These are co-primes, right? 3 and 5, co-primes. 4 and 5, co-primes. They do not have any common factors. Remember this one. So these are co-prime. These are called co-prime numbers. You know it. I have already told you. Again I am revising. So root 2 is equal to A upon B, and A upon B are co-prime, and B is not equal to 0. You know, rational number denominator should not be 0. So this is our assumption. Now let us solve it now. So B will be taken to the left hand side. So B will be multiplied by root 2. This is called multiplying by B. So root 2B. Arrange it. Now squaring both the sides. So you have to square this both the sides. What is the square of root 2? 2. What is square of B? B square. And what is the square of A? A square. Now 2B square is equal to A square. You see that there are two numbers here. 2 is a number and B square is also a number. So the A is expressed in the form of two numbers. That means 2 divides A square. If suppose we take like this, 2 into 3 is equal to 6. It shows that 2 divides 6 or 3 divides 6. That means 2 is a factor of 6. 3 is also a factor of 6. This is the same thing here. 2b square is equal to a square. Then 2 divides a square. That is 2 is a factor of, directly you can write, here I have written, there is no need like that. You can directly write 2 is a factor of a square. Now when 2 is a factor of a square, then 2 divides a. Now for example, see here, 2 divides 16. Suppose 2 divides 16. This means that 2 must divide the square root of 16. So 2, hence 2 divides square root of 16, that is 4, because this is a 4 square. So 2 divides 16, it means that 2 divides the square root of 16, 4. This is theorem. We call it as a theorem. Here see, again I will see, 2 divides a square, hence 2 divides a. Take this statement as first, because I am going to use this one. Now when 2 divides a, that means there is a one more factor of a. When 2 divides 4, then there is another factor of 4 also. Let that factor be c. So hence a is equal to 2c, or let a is equal to 2c, where c is another factor. Because after dividing you get quotient. When 2 divides a, then you get a quotient. That quotient is c. So a is equal to 2c for some integer c. Now a is equal to 2c, we will substitute in this equation, earlier equation. So a is equal to 2c, and substituting a is equal to 2c in 2b square, this is this statement. 2b square is equal to a square. So 2b square is equal to a, replace a by 2c. So 2b square is equal to 2c square, that is 4c square. Dividing by 2, this is dividing by 2, both sides. So b square is equal to 2c square. So here again we come to know that this 2c square is equal to b square. Now there are two factors, one is 2, one is c square. This shows that 2 is a factor of b square. So 2 is a factor of b square and 2 is a factor of b. This is very important to show. Here in this first statement we have shown 2 divides a, and here also we say that 2 divides b. 2 is a factor of b. I have written directly factor. You can write directly this factor. So 2 is a factor of b square. That means 2 is a factor of b by this theorem. So now 2 is a factor of a, 2 is a factor of b. So this is not possible. Here not from first and second what we come to know, 2 is a factor of a and b. But it is not possible. Why? Because a and b do not have any common factor because they are co-prime numbers. So but it is not possible as a and b are co-prime numbers, hence a and b do not have any common factors. So hence our assumption, what we assume, root 2 is rational. That is not correct. Hence root 2 is irrational. Hence proved. Now similar way, in the same way you prove that root 3 is irrational and root 5 is also irrational. Now you remember all these steps, write down properly, 2-3 times you solve this question, then only you will understand. And in next video I will show you the solution of root 3 again. So that will be your practice. It's very simple, 2-3 things you have to remember. So practice it till I send you another video. Okay guys, thank you.